Hello everyone. So this is Ajeet Singh, and we have Wamiq, Kevin, and Joshua also in this group, and we are going to discuss about our project, which is Google Store Customer Revenue Prediction. This project is about creating a prediction model for data set which we downloaded from the Kaggle, and it's more about the uh, marketing investment, how a company can put their budget in the concentrated format to the target customer so that they can have a expected revenue. So let's go through that slide which we created. So the first slide is about our agenda. So we're going to first describe about the project overview, then problem understanding, source data understanding, and then we will modify our data so we can use in our model. We will interpret the data and relate with different elements. We're going to have different models and validations. We will also see the feature importance, like how those attributes are impacting on the prediction. So in the project overview, this is our flow where we are collecting the data. That is a G store, that is called Google Store merchandise data, and it's data about the customer who are basically using the websites, uh, and they we collecting. I mean, Google collecting the how much transaction revenue generated from that user. So we're going to use the data, and we're going to basic understanding what the elements in that data, and then we will pre-process, interpret the data with the different elements relation, and build a model. So there are three models: multiple linear regression, ridge regression, and lasso. And we're going to use the tenfold cross validation in all the three models. At the end, we will going to show the feature importance of all the elements which we use in the prediction and how it's going to impact on the our prediction model. So as the business problem is about the marketing teams want to make appropriate investment in the promotional strategies to attract the potential customers. As we know, like in the business, every business almost, we have very small percentage of customers who produce most of the revenue. And that's why it's very useful if marketing budget is concentrated or to the target customers so that we could have maximum revenue generated. It's very difficult if we don't know those hidden information about the customer who are potential customer to generate the revenue. And that's why we're going to build a predictive model using this data set, and that will basically predict the total revenue per customer wise. And that's basically help in better use of the marketing budget. In this study, we will also interpret the most impacting elements on the total revenue prediction using different models. So let's start now. So the third slide about the source. So as I told you initially, it's about the GeoStore customer dataset, and we downloaded from the Kaggle. It is one of the competition going on in the Kaggle website about this one, and it's proposed to design a model in the R language. So when we downloaded this dataset, we found almost 900K observations and 12 attributes, and some of them are in the JSON collection set. So it means like it has sub elements in that attribute. These data sets are collected by Google from 2016 to 2017. So almost 1.5 years of data we have, which includes the 2 dates, 4 numeric identifier, and 7 categorical attributes. The categorical attributes are, some of them are as in the JSON format, like device, geo network, totals, and traffic source. And these are having subset of data, and we have to divide this to understand better. One of the important element is called transaction revenue, which is available in the total JSON. And this is going to be our response element. So this is very important because at the end, we are going to predict the transaction revenue. So in next slide, we will discuss about the 12 attributes and their description. So here is the 12 attributes which we downloaded, and it has various kind of data set like channel grouping, like what channel user have used to come to the store, date on which user visited the store, device, which device user has used, either mobile or desktop or something. Uh, there is a visitor ID, unique identification, unique identifier when they visit the Google store. There is a geographical network also, the which place the user belongs, and then the session ID when they visit the store. There is a column called totals, which includes the uh, number of hits or page views, how many are total revenue generated from that page views and all. There is a traffic source also, like what network they have used, which is a Verizon, .NET, AT&T, what traffic source they use. It's all detail is here. Then there is unique visit ID and visit number, which identify the uniqueness of each customer. And then visit start time. This is a timestamp when they initially started the browsing the website. So this is all 12 data elements in our source. This is a sample for the same data source. So this is, as I told you, these are 12 and their data type. So channel grouping initially is a character data type, and it has some data values like direct, organic search, referral, etc. There is a date column, which is in this format, and in the source, it is called, in its data type is integer. So we have to change this all data which is not correctly mapping. So then if you see the device, it's collection of JSON, which is basically subset, and it has multiple columns inside. So we have to divide this subset in a small columns. So we will see that in the next slide. So these all elements you see are, some are the useful, some are not. So we will figure out. Now, next one is the data pre-processing. So this is very important because we have 900K records, which is a huge volume of data. So first thing what I did is I filtered only those records which have transaction revenue. And I removed all those records which don't have transaction revenue, so that we should, first of things, like we should get only valuable records which can help in our prediction. And after prediction, we got around 11,516 observations, which is very less. And now it's also improve our performance when we running our model. Second thing I did is date column. That was initially character, so I converted back in the date class. Then there is a visitor time, a start time. That is, I converted in the timestamp using the POSIX format. And then all the 5 JSON columns like device, geo networks, total, traffic source, all these 5 JSON columns I divided in a small distributed in the subset. Whatever the subset inside, I divided into small columns, and I dropped the JSON columns. Then I also found there are some column have values which is not meaningful, like unknown dot unknown, not set, not available demo data set, none, nene, etc. So this is very varieties of not available data set. So I converted all of them in the one single value, which is called NA. So NA means unknown value. So it's aligned with all data set. Now drop the newly parsed JSON columns that have only one unique value. So there is one column which have very low cardinality. It means like all the values are same among all the observation. In that case, those columns are not valuable for that, and I dropped that one. So one of them is a socially is a person is socially engaged or not. So that is not very helpful. So I dropped that one. Then convert all the newly JSON columns like hits, page views, new visits, transaction revenues. to the numeric, because this is a numbers, and this is going to help in our prediction. So I converted back in the numeric format. And also I noticed that the transaction revenue column is multiple of 10 raised to 6. So it's very huge number. So I divided back it with the 1 million, so that we can have a range of data in our prediction. So this is the sample data set after doing the pre-processing, and we can see here the date is converted to date. Some of the number like full visitor ID to number, double is called number only. Visitor number, visit ID is also integer. If you see, there are some new columns added here, which is a division of the JSON column, like browser, operating system, is mobile, device category. So now we see the exact data here. Some of the sample data is shown in the right side. So after doing the pre-processing, we got 30 variables. Initially it was 12, after that we got 30 variables and 11,515 observations. Same way, here we see some more data elements like hits, page views, transaction revenue. Yeah, this is the one of the important transaction revenue, and that is going to be our response column. It is a double format. So because I divided with 1 million, we can easily read this $37.86 or something, but this is just a value which will help to predict. Okay, so yeah, so some of the values like add content, add words click are not available. So I dropped those columns which have no impact on our prediction and there is no valuable information. So I dropped all these columns. We will see in the next slide about all the data interpretation. So let's see. Yeah, so let's start with data interpretation, where here it's so about missing data. So this is a percentage, and you see the ad content is almost 100% data is missing. Same way slot and the click info, these are data is not available, and so it's not going to help in our prediction. So I'm going to remove this. And in the right side, if you see, we have all the data which is available, because 0% of data is missing. So like visit ID, source, page views, is mobile, hits, and all this data is very useful for us in prediction, and we're going to use these elements. So as I told you initially, we have chosen transaction revenue as our target variable, and the revenue from the single visit range from the $0.01 to 23,000. So it's like ranging very big range. And if you look the distribution of the log of transaction revenue, then the mean is exactly almost it's coming to the 4. So 4 is our approximately mean for the log of transaction revenue, which basically creates a normal distributed, and it's looks very important to become our response. Now second one is the daily visits and the revenue over the time period of the data set. So data set we collected starting from October 2016 to around July 2017. And in this 1.5 year, if we take the range of daily visits and the revenue, the first slide is so the daily visits, where you see its visit is increased in December 2016 or something. And similarly, it's around mid of the year in 2017 also it's increased. So these hits, these visits can show when it is increasing and when it's decreasing. But if you just see over the year, it's almost crossing the straight line here. So it's a very smoothing line which indicates daily revenue, and the fluctuation aside of this a smoothing line. Same way for the revenue. So revenue also, you see, almost is a stable, but some period it's going very high, maybe due to some seasonal marketing, or maybe some festival occasion or something. But we have to figure out that one, like which period it's increase and why. So this is about daily visits and revenue over the time period of dataset. And then to understand better about our revenue, I have also graphed on the hourly basis. So if you see, in one day we have 24 hour, and in that 24 hour, if you see, on the fifth hour and the 10th hour is decreasing, and then after that it's increasing, the visits are increasing over the day. So this is like end of the day, it's like it's going high. And same way for the revenue. uh, so it's over the day, it's decreasing initially, and then after 10th hour, it's increasing. So, I mean, the person can, and the marketing officer can concentrate on that hour, so better predict the model. Then it's about the visit and mean revenue of by the channel grouping. So channel grouping are like a referral, organic search, direct, paid search, display, social, affiliates. So these channel groupings, if you see, referral is the highest visits, organic search are after that. And if we just take the revenue, the display channel group is highest revenue generation, and then direct is little less than the display. But if you see the visits, I think display is a very less visit. In that less visit, we are generating a high volume of revenue. So it means this is very important, I mean, channel group, where very small number of visits, or maybe very small number of customers who visit the display uh, channel group is basically generating a huge volume of revenue. And if you take the referral, a referral, very high number of visits, but the revenue is around at the third level in our revenue generation graph. So even revenue is important, but you have to invest a lot to get small revenue. And in the case of display, if you invest less, you're getting very high uh, revenue here. So the next slide is about the distribution of visits and revenue by device operating system. So you can see it's a Macintosh and Windows are highest used operating system to visit. And same for the revenue generation, Macintosh is the highest operating system we used in the revenue generation. So this is simple. I mean, iOS operating system, Android are very less. I mean, most of the people are, I think, using a desktop, and that's why it's more widgets and revenue. In case of mobile, let's see, maybe in next slide I have created, yeah, this is about the device browser, where where we can see the Chrome website browser is basically a number of widgets are more in the Chrome, and same way revenue is also generated more in the Chrome website. Revenues, the second, if we just remove the Chrome and just concentrate on the Safari and Firefox, so number of visits in Safari is more, but the number of revenue generation in Safari is less compared to Firefox. So this is about top 10 browsers distribution. And then distribution of records and revenue by device category. So we have three kind of device category. One is a desktop, mobile, and tablet. So users are visiting from all these machines, and desktop is the highest use. So if you just in the 11,000 record, if you just distribute the records in this three category, then desktop is the highest use, and after that mobile, and then tablet. Same way for the revenue generation. So desktop visits are more revenue generation compared to mobile, and tablet is very less. Now this is the slide about the distribution of log revenue. by mobile and non-mobile devices. So we found like desktop is the highest use, right? So just here is mobile is true for the yellow. So if you just take the log revenue, and we found like mobile uh, is the highest revenue generation compared to non-mobile. The reason I'm talking about is if you compare both of them, non-mobile and mobile, we found that most of the revenue, highest amount of mobile revenue generation is coming from the mobile compared to non-mobile devices. Then total transaction revenue by continent. So the user are distributed all over the world, and we found the America here is the highest continent. I mean, where highest number of revenue is generated, and after that Asia, and then Africa. Oceania is the last number of that. And then I also have distributed the transaction revenue by the country. So it's a range from the 0 to 15. And if you see the highest blue, which is a 15 highest uh, transaction revenue, that is in the North America side. So this is a dark blue. And if you just take the right side where Asia, here we have a light blue, which is around 0% to 5%. And then Australia, and then something in Africa side, South Africa, it's coming around 5 to 10%. So our market should be more concentrated in the North America and a little bit in the Asia. Now, when we visit revenue by network domain, when we see that we found that not .net and .com is the highest website, which network domain website, which is used in the visits, and the same for the revenue generation. I mean, most of the uh, network are under the .net or maybe .com domain. There are some others which are very minor, which is not very impacting on the revenue generation. So we should also notice this to network domain. Yeah, this is very interesting about the bivariate distribution plots for page views was transactions, and then hits was transactions. So take the first page, a first screen where I compared the page views was transaction revenue. So in the page views, if you see the page views, the right side is the basically transaction revenue, and the top histogram is the log is the page views. So if you see the more concentration, the highest revenue part, more concentration is aligned with the page view. So if you see the page view is more high when the transaction revenue is more high, or I can say when the transaction revenue is more high when number of page views are high. So this is a concentration part. So this is like clear that there is some relation, and a very strong relation exists between the page view and transaction revenue. And same way for the hits. So this is the right side where we have transaction revenue, and then top is the number of hits. So again, number of hits is very much aligned with the transaction revenue concentration. So these two are very important element in our prediction. And then I have distributed the visits and transaction revenue by traffic source, and that is one of them. Traffic source is the medium, where we have referral, organic, CPC, CPM, affiliate. So these mediums, if we just compare or distribute the visits, we found that referral and organic are highest for visits, and same for the revenue as well. Yeah, so that about we discussed about data interpretation. Now we're going to discuss about data model and validation, which we already discussed in the initial slides, that we are going to build three models, multiple linear regression, Ridge regression, and lasso. And we're going to use the tenfold cross validation. And these are the prediction variables which we're going to use. After doing our analysis, we found that country, device category, operating system, channel group, widget number, and page views are very important element which can help in our prediction. And as we already know, the response variable will be transition revenue. In the end of this slide, we will also discuss about the feature importance, like how these elements are impacting in our prediction. So I will hand over this session to Wamiq, and he is going to discuss about more on this. Thank you.
Okay, so thank you, Ajeet, for explaining the data. And now I'll explain a bit of the prediction models and the variables and the response variable that we used based on the data that we have filtered earlier, which we thought that is more these variables. Based on the previous slides, we observed that these variables, these 6 variables, country, device category, operating system, channel grouping, visit number, and page views, have, like, some of them have good positive impact on the revenue, and some of them might have less positive impact. So based on these, I believe we can we have used 3 different models to see how or to see which model performs best in terms of uh, like to fit the data on. So we'll go to the multiple linear regression first. So since we if you go to the next slide. So here we have used multiple linear regression, and we can see that the model is the model that we ran have different outputs that it is showing us. And since we have seen that the that f static value is around 19.54, which is not equal to 0. If you want to run the hypothesis test on it, that if this value approaches 0 or is close to 0, then this model might not be a best fit for this kind of data, but which shows that it is okay to use this model as well. Then further, 2 other important models that we have used, if you go to the next slide, is ridge regression, where we use alpha equals to 0, and we have a min lambda terms which help us to identify the different kind of mean squared errors to be ran over that. And then the next one we used, if you go to the next slide, is lasso, where we use alpha as 1, and we can see 2 outcomes from this also. So in the end, we have in the next slide, we have compared the mean squared error for all the 3 models, and we found, and based on that, we can see that lasso is since lasso has the least value for the MSC, so that might present the best prediction for this kind of model. And there are other regressions also that we might use on this one, but since we just need to compare this data, and this data is huge initially, so we just use these 3 regressions to just fit our models on. And after that, we have in the next slide, we have also tried to compare uh, uh, for a different kind of variables, how is their importance in to compare the 3 different models that we use. We have checked, we just want to see how important is what variable for what kind of regression. So as we can see, for the multiple linear regression, the our variable country seems to be on the higher importance compared to ridge and lasso. Same goes for, like, for example, operating system, which shows less importance in multiple linear regression, but it shows more importance in ridge and lasso. So that's how we can we try to show, like, which sources that the consumer or the retailer should use to project their products based on, for example, if operating system, if there are more Macintosh users, so they should advertise their products more on those products. I mean, those operating systems. They should improve their advertising, so that can further improve their revenue based on that. Uh, I think we have we still uh, uh,
Thank you, Wamiq. Yeah, I think we have covered almost all the models as well as the basic interpretation. And this we choose this three model, and I think this is we found that Lasso is definitely the best. But there might be some other model also in the, or maybe the other way to handle our prediction, which can better perform. And that's, I mean, we leave that one for the competition, but what we learned here is that the data and their relationship with each other is so much important to understand before choosing any model. And also, when we are designing our model, we should have a proper cross validation method available. We should also have a proper data set which basically help in the prediction, and we should also avoid any kind of bias, some kind of data which basically overrule uh, your predictions. So we should be very careful from those bias elements. So this is all about our project, and if any question, please feel free to ask. uh,
also based on the variables that we have. For example, like we also need to we also need to take care of the multicollinearity between the variables. If they are so much correlated to each other, that might also affect the prediction overall.
yeah, exactly, yeah.
That is something more we have tried to avoid in this.
Yeah, good. So yeah, that's all we have here. So thank you, everyone, and feel free to reach me, Ajeet, Wamiq, Kevin, and Joshua for any question. Uh, Thank you very much. Bye.